In this video, we're going to use implicit differentiation to compute derivatives of inverse trigonometric functions. Let's start with y equals sine inverse of x. Well, then we can say that sine of y is equal to x. Now differentiate both sides with respect to x. d by dx sine y is equal to d by dx of x. So that gives us cos y times dy by dx is equal to 1. Since y is a function of x, we have to use the chain rule on the left hand side, which is why we end up with the dy by dx term. So rearranging gives dy by dx is equal to 1 over cos y. But remember that sine squared y plus cos squared y is 1. So that gives us cos y is the square root of 1 minus sine squared y. And also, we know that sine y is x. So we have cos y is the square root of 1 minus x squared. Hence, dy by dx is equal to 1 over the square root of 1 minus x squared. The derivative of cos inverse x is very similar to the derivative of sine inverse x. In fact, if y is cos inverse x, dy by dx is equal to minus 1 over the square root of 1 minus x squared. To check you understand the method, you should try to compute this yourself, using the worked example of y equals sine inverse x to help you. Let's finally take y is equal to tan inverse x. Then tan y is equal to x. Again, we differentiate both sides with respect to x. So, sec squared y times dy by dx is equal to 1. Here we've used the chain rule again. We've also used the fact that the derivative on tan is sec squared. This is a common result that you should memorise. However, if you want to see why this is the case, you should watch the earlier video in this series about differentiating tan x. Now, we'll make use of the following result. Tan squared y plus 1 is equal to sine squared y over cos squared y plus cos squared y over cos squared y, which is equal to sine squared y plus cos squared y all over cos squared y, which is equal to 1 over cos squared y, which is just sec squared y. So sec squared y is equal to tan squared y plus 1. Subbing this in gives us tan squared y plus 1 times by dy by dx equals 1. Hence, dy by dx equals 1 over tan squared y plus 1. But remember that we know that tan y is equal to x, since y is tan inverse x. So we can write dy by dx is equal to 1 over x squared plus 1.